So I'm going to talk about byte pair encoding. Um, so if you wonder how the computer processes or the AI model processes natural language without getting confused, here's a short answer that kind of gives you an overview of what it does. Because it's not really reading like you and me. It doesn't see apple and think of a red fruit. It sees numbers. But the question is, how do we get from a sentence to those numbers without breaking the AI's brain? So back in the day, uh, they the models, the way they were set up was that uh, it was basically a list of words that were in a vocabulary. The vocabulary contained all the possible words that were likely to appear in a sentence. And they were all numbered from zero to whatever the size of the vocabulary was. So the downside was that if, for instance, all of a sudden we had a word that was not part of the vocabulary, like zoodle, it would cause a crash and it would result in an out of vocabulary error or OOV. Um, but now we have a different way of the actually the language models work, and it's not the same. So we have three different levels where the model can encode language. One is at the word level that we have the vocabularies. One is the letter level, which all the alphabet or characters that are present. And one is that in between the two, and that is what we call a byte per encoding. And what it actually does is we break words into pieces or what we call subwords. Um, and even then, some of the words become tricky. So we have what is called a byte level byte pair encoding. As I said, instead of looking at letters, we look at bytes. Everything in a computer is a byte, right? Even an emoji like, a rocket emoji or a smiley emoji, weird symbol, or, different languages that we have never seen are a string of bytes. By tokenizing at the byte level, the AI becomes a master of Lego bricks. So that's why we refer to this byte per encoding as the Legofication of language. So we're looking at the building blocks of language. To give you an example, the AI model, the language model, does not see the word unbelievable as one giant word. It kind of scares the language model. It sees on plus believe plus able. And even it has never seen unbelievable before. Let's say this is a new word. It can kind of make sense of it because it know what on means. It kind of means negating some uh, meaning. It know what able means, and it also knows what believe means. So, like giving AI a box of Legos, and say, okay, build a new word with these, Lego pieces. It can build any word in the universe, even Zoodle, because it has the basic blocks to put it together. Um, this is why ChatGPT or Gemini or these language models do not all of a sudden crash when you make up a word. It's also why it can speak 50 different languages and understand emojis. It's not memorizing a dictionary, it's learning the DNA of the bytes or what the language is made of. So next time you see a token count on your API bill, just remember you're paying for the Legos and byte level byte level byte pair encoding is the reason those Legos never run out. Thank you for watching. And if you're interested in learning more about byte level encoding, let me know in the comments, and we'll make a video that kind of responds to what you're asking in the comments. In natural language processing, computer vision, robotics, I'm here to help you um, get familiar with the world of AI. Thanks for watching again. See you in the next video.